Katherine Sanders is one of my graduate students. She currently lives at Shealy Farm. Is working up there, and is working currently on a research project looking at the differences between in vitro digestibility and in vivo digestibilities.
My name is Katherine Sanders, and I completed my undergrad at State University in Agricultural Sciences. I knew I wanted to continue on in my studies, and so that led me here to Missouri State. I live out on Shealy Farm, and my research is being conducted here at University Farm.
This study is one, the idea behind it is there's two different methods to determine digestibility. One is in vivo or in animal. And so that is obviously the gold standard of we have what the animal digestibility is. So we measure the amount that goes in, the animal consumes, the amount that is excreted, and the difference is going to be apparent digestibility. It is very difficult and time consuming, so each one of those periods for one feed is roughly 21 days, and so we did 3 different periods, and so we're looking at 63 days worth just to get a sample of 2 different feeds.
So my study is comparing in vivo to in vitro dry matter digestibility. So right here is the in vivo portion, so that's within the animal. And so knowing the amount of forage going in and collecting the fecal going out, as you see here with these fecal collection bags on them currently, we were able to tell how much of the different forages were being digested. We have 3 sears here for 3 trials for a Latin square design.
The advantage of an in vitro means in lab, and so we use what's called a Daisy 2 incubator, and we can put those same samples in the Daisy incubator using rumen fluid that we collect from a sample steer. We can run, I think it's 24 samples at a time instead of having to do 1 at a time. But because it is a in vitro and in lab and it's not the actual animal, it's very difficult to compare multiple runs together. And so the idea is to compare these two, see how they compare in vitro to in vivo, but also to use the same haze that we have used for the in vivo, the in animal portion, and know that we have a set of standards that we can always compare back to and create a known value. So if that in vitro run is off a certain number of percentages or whatever, we can adjust that back to where it is similar to the actual in animal value.
The trial is 21 days. The first 7 is the adaptation period. So those 7 days allow whatever was in the stomach prior to fully digest and be expelled. The second week is the restricted diet, where they are restricted to 80% of their average intake from the week before. And then the third week is the fecal collection week, so a total of 21 days. The forages used here, samples have been taken, dried, as well as ground through a 1 millimeter screen through a Wiley mill. And so that 1 millimeter size matches what that forage size is within the rumen. And so that is placed into digestion bags at 57, where they go through digestion with rumen fluid and incubation, and then fiber will be analyzed following. Daisy incubator that we'll be using for the in vitro portion. So this simulates digestion. So within here is the digestion jars. And so you'll put the feed bags evenly on each side. Rumen fluid will be placed in 4 jars. And in here, once it's turned on, you'll press the on heat and on to rotate, and then it'll go for 48 hours. Once the bags are done in here, they'll be dried, rinsed, dried again, and then we'll go over to the fiber analyzer that will test for fiber as well as potentially ADF and NDF.
I'm one of Dr. McGee's other graduate students, and I'm also the farm operations manager down here at the DAR Center. Part of the importance of Katherine's research is the data that she's going to collect. Once her study is over, we will be able to use that information to determine what kind of feed rations we can develop for our university herd and be able to look at different effects such as the rate of gain and feed efficiency, especially when it comes to bringing cell groups for our production sale in October. That information is going to be important to develop a solid feed ration that we can use in later years.